Welcome aboard my virtual space station, orbiting the Earth over 200 miles up. And to the first video in our Science Museum series, looking at how science is helping to tackle the planet's climate crisis. From here you can see that thin blue layer surrounding the planet. That's the air we breathe, and the reason people and animals can exist at all. By the time you're just 50 miles up, the atmosphere has almost disappeared. Up here in the blackness of space, there's pretty much nothing. It's a vacuum out there. So our atmosphere is precious, but unfortunately, humans have been messing it up, leading to our climate changing. Jariah's down on Earth to look at how this started happening. Hey Jariah, where are you?
Hi Scarlett, I'm in the Science Museum in London, in the Energy Hall, surrounded by so many amazing old machines. This is the actual steam engine used to power a mill in the north of England making cloth.
Fueled mainly by coal, steam engines started to be used widely during the 1800s, and they completely changed how humans live on Earth. Before steam power, people used horses and other animals to get about and help them work, often in the fields. They used windmills to grind grain to make food like bread, and to travel really long distances, they'd get on sailing boats, also powered only by the wind. But the invention of engines was a large part of what was called the Industrial Revolution.
This is Puffin Billy, the oldest surviving steam locomotive in the world. Built in 1814, it's over 200 years old, and it directly replaced horses in a coal mine.
Soon, steam trains and ships were whisking people around. Big factories grew up, and then came steel and electricity, cars and aircraft, completely transforming our lives.
But for all the positives of this revolution, there was a downside for the planet, wasn't there?
Yes, all these machines and industries were powered by fossil fuels, coal, oil and gas, and that was a disaster waiting to happen.
Especially as the planet's population was increasing dramatically through all this. It was only around 1800 that the number of people on Earth hit 1 billion, and since then it's grown dramatically, till there are now over 8 billion of us. And in the last 100 years or so, the amount of fossil fuels burnt by people has also gone up hugely. For example, coal, gas and oil in power stations to generate electricity, and fuel like petrol and kerosene, which all comes from oil to power cars, trucks and planes. This burning of fuels produces vast quantities of carbon dioxide gas, or CO2, which escapes into the air. CO2 is a so-called greenhouse gas, which traps heat in the atmosphere, a bit like a greenhouse, making the planet hotter. It's known as global warming or global heating. And it's already having a big effect in some parts of the world. Weather patterns are changing, leading to record high and low temperatures, with more fierce storms and serious droughts. At the 2015 Climate Change Conference in Paris, nearly 200 nations agreed to try to keep global heating to at most 1.5 degrees above the level seen before around 1900. It means countries across the planet have promised to make big reductions in the greenhouse gases they create. Their target is to reach what's called net zero for carbon emissions by 2050. In other words, that by then, they'll be removing as much carbon dioxide from the atmosphere as they add. There's still a long way to go, and in this Science Museum series, we're looking at how science and technology is helping to make it happen.
We'll begin with a new take on that ancient machine, the windmill. Listen to that. That's the amazing sound of a wind turbine. They're so much bigger than I imagined. I mean, each one is around 120 meters tall. And each of those 3 blades are 45 meters long. Their goal is to make greener electricity.
I met up with Diego, a senior wind farm engineer.
So, Diego, you have 6 turbines on this wind farm, and it's interesting that you've gone back to a form of energy used by humans way before the Industrial Revolution.
Yes, that's right. It has taken a long time just to get the technology to build wind turbines big enough to be able to generate electricity for a large portion of the country. I think the blades now are 45 meters on this wind farm and made out of fiberglass, and it's a strong and lightweight material that wasn't available before the Industrial Revolution.
But how does a wind turbine make electricity at all? Well, it's like how a dynamo, like this one on a bike, powers your light. Here, the wheel is what turns the dynamo. Similarly, the wind turbine blades turn huge coils made up of wires that can conduct electricity. They're positioned inside powerful magnets. And as the coils pass through the magnetic field, it's an amazing fact that electricity starts to flow through the wires. Alternatively, the magnets can rotate as the coils stay still. It's got a big name, electromagnetic induction. It was discovered by a brilliant British scientist, Michael Faraday, around 200 years ago. As well as wind, some of the other things used to make the coils or magnets turn are water, for instance rushing by in a hydroelectric dam, or of course, the power of steam, much used in everything from traditional power stations to nuclear and more.
Thanks, Scarlett. So, Diego, how much energy actually comes from here, and do you think it can really replace a power station?
Well, in 2023, this wind farm alone generated 35,000 megawatt hours, which is enough to power 10,000 homes for the whole year.
Wow.
Yeah, that's correct. Yeah.
So what if the wind goes in the wrong direction?
Well, if the wind changes directions, the turbines can sense where the wind is coming from, and they will point themselves to the wind. So there's a sensor on top of the wind turbines that you might be able to see. That's where all the sensors are to detect the direction and the speed of the wind, so the turbine can control itself.
Wow, that's really cool. So wherever the wind is, they can just sense where it is.
Yeah, that's correct.
And if the wind stops completely here, it might still, of course, be blowing somewhere else in the country. Or we might be able to turn to different types of renewable energy.
We'll be looking at solar power, power from the sun, in our next video. But another natural energy source is the power of the tides, and it comes mostly from another heavenly body, our moon. The moon's gravity affects Earth's oceans, giving us tides twice a day. But how do you capture that tidal energy? Well, this amazing craft is the Orbital O2, the most powerful tidal turbine in the world. It's over 70 meters long, and each of its 2 huge turbines rotates in the tide, generating a megawatt of electricity. Enough to power 2,000 homes on the nearby Scottish Orkney Islands. And how about this? Swedish company Minesto have come up with this cool idea. A kind of underwater kite tethered to the ocean floor that moves in a figure of 8 in the tidal current, with an onboard turbine, again generating electricity. It's estimated that more than 10% of the UK's energy could one day come from these and other ingenious tidal devices. So as we've seen, to protect our fragile planet, scientists are turning more and more to some of our most powerful renewable sources of energy: wind, water, and the mighty sun itself.